welcome back to Chemistry Auto. Today we are back with another chapter. The chapter's name is Acids, Bases and Salts. Alright, so we are going to divide the chapter into three portions. First we're going to do acids, their reactions, and bases, their reactions, and then we'll move on to salt formation. Okay, so let's start. So the chapter's name is Acids, Bases and Salts. Alright, so first of all, what is an acid? We need to discuss that. So, acid is any substance that gives H positive ion in aqueous solution. So, a substance that gives H positive ion in aqueous solution. Mind it, the solution needs to be aqueous. Alright, now let's do some examples first, and then we'll move on to strong acids and weak acids, the differentiation between them. So let's start with examples. Alright, you need to know them as well. So let's start. So HF, hydrogen fluoride, it's liquid at RTP and it's a weak acid when dissolved in water. Then we move on to HCl, it's gas at RTP and it's also a strong acid. Then we move on to HBr and HI. They are also strong acids. HI, it's also a strong acid and gas in a gaseous state at RTP. Alright, now we have H2SO4. It's liquid at RTP, so it's also a strong acid. Next we have H2CO3 or carbonic acid. It's liquid at RTP and it is a weak acid. Then we have H3PO4 phosphoric acid. It's also a liquid at RTP and it's also a weak acid when dissolved in an aqueous solution. And the last one is nitric acid or HNO3. It's also a liquid at RTP and it's a strong acid. Alright, great. Now when we have done this, when we are over with the examples, we need to move on and clear the concept of what do I mean when I talk about strong acids and weak acids. So let's move on. Alright, so what is a strong acid and what is a weak acid? So a strong acid completely dissociates in an aqueous solution. Alright, and a weak acid dissociates partially in an aqueous solution. So a strong acid completely dissociates in an aqueous solution, while a weak acid partially dissociates. Alright, now how do we show it and what are the examples? We'll do it just now. So partially dissociates in an aqueous solution. Alright, so what do I mean when I say a strong acid? So for example, if I have H2SO4 and it's liquid at RTP and I add it in water, what I'll get is 2 moles of H positive ion and a sulfate ion. Alright, and both will be in aqueous conditions. Right? Now this is what I call as sulfuric acid. If you notice, the acid is because of the H positive ions that it has released in an aqueous solution. Alright? Next, it's HNO3. It's a liquid at RTP. When I add H2O, it gives H positive ion in aqueous condition plus nitrate ion in aqueous condition. Alright, so these are just a few examples of strong acids. Now moving on to weak acids. So let's see, hydrogen fluoride. Now let's clear up a few things, right? Just right away. When HF is in its RTP state or its standard state, for example, HF in this case is liquid, I call it hydrogen fluoride. Alright, so this is hydrogen fluoride. However, when I add water and it dissociates to release H positive ion and fluoride ions in aqueous conditions, I call it hydrofluoric acid. Similar is the case with hydrogen chloride and hydrochloric acid, hydrogen bromide and hydrochromic acid. These are few things that should be very clear in your mind. Alright? So this is what a weak acid looks like. Now if you notice, there's a difference between this sign here. In a strong acid, it's a complete arrow. In the weak acid, it's double-sided arrow. And there's a reason for it. When a weak acid dissociates, it gives H positive ion as well as another anion. However, the anion and the H positive ion are simultaneously reacting back and forming hydrogen fluoride. Alright? So I hope this makes things very clear in your mind. Now moving on, let's do another example. Let's do carbonic acid. Now carbonic acid is an exception. You cannot say hydrogen carbonate. It's not right. It's an exception. Just like phosphoric acid. It's an exception. Or sulfuric acid. It's an exception. We'll call them with their names, whether they are in RTP state or the standard states or in an aqueous state. We'll call them by similar names. Alright, so hydrogen carbonate, when it dissociates, it forms 2 moles of H positive ion plus carbonate ion. Now both in aqueous condition, however, they react back to form hydrogen carbonate as well. That's why they partially dissociate in aqueous solution. Now let's do another example. Let's move on to carboxylic acid. All carboxylic acids are weak acids. So here I have drawn methanoic acid. Now when it dissociates, it forms a methanoate ion and an H positive ion. Now this is methanoic acid. This is methanoate ion. And mind it, all carboxylic acids are weak acid. Now, if some of you have a question in mind that what are carboxylic acids, let me clarify it right away. They are a homologous series in organic chemistry. We'll be studying them in greater details when we move along in the syllabus. However, just for argument's sake, just for mentioning it, I have told you guys that all carboxylic acids are indeed weak acids. Now let's move on. Okay, so now we move on to indicators. There are 3 indicators in your syllabus, and I recommend that you learn by heart the colors of each indicator in each of the 3 conditions, either acidic or neutral or alkaline conditions. So first of all, the indicator that is in your syllabus is methyl orange. So its color in acid is red. Its color while it's neutral is orange, and in an alkaline solution its color is yellow. Very important stuff, very important. Next, the indicator in your syllabus is universal indicator. Now its color does vary. Its color varies from red to blue. However, a general color that you need to remember is that in acid the universal indicator is red, in neutral conditions it's green, and in alkaline condition it's blue. Next, phenolphthalein. So we have phenolphthalein. Now it's also pronounced as phenolphthalein. So the color of phenolphthalein in acid is colorless. In neutral condition it's also colorless, and in alkaline conditions phenolphthalein is pink. Alright. Next, we have some uses of acids that, in my opinion, every student of O levels must know. Alright, so the first acid that we have is HCl. Now, it is used for pickling of metals. Alright, so it's used for pickling of metal. Alright, so what is pickling? It's just the removal of oxide layer from the top of some metals. For example, aluminum and magnesium, they form oxide layers on their top surface because it reacts with oxygen. So we add HCl and do a process known as pickling. So pickling of metals, that is the removal of oxide layer. Next, the acid we have is sulfuric acid. Now sulfuric acid has multiple uses. It used to be one of the indicators of economic growth. The production of HCl used to be a fantastic indicator of economic growth because it's used in almost every industry. Alright, so it has many uses. First one is that it's used in car batteries. So it's used in car batteries. Next, it is also used in fertilizers. It's also used in paints, dyes, etc. So it has multiple uses, right? So next we move on to carbonic acid. When we talk about carbonic acid, It's simply used in fizzy drinks. So fizzy drinks. Next we have nitric acid or HNO3. Nitric acid is used in fertilizers as well as in explosives. Alright, we move on to phosphoric acid or H3PO4. Phosphoric acid is also used in fertilizers. And finally we have ethanoic acid, that is CH3COOH. It's used in vinegar. Alright, so these were just some uses of acids that we ask you usually for 1 or 2 marks. So next we have the physical properties of acids. Then we move on to physical properties of acids. So there are a few properties that you need to remember because we ask usually 1 or 2 marks question on these. First of all, that their pH is less than 7. They have sour taste and their aqueous solution can be used as electrolytes. Can be used as electrolyte. Alright, so these properties are physical properties. If we ask you write few physical properties of acids, you can write any of these 3. However, if we ask you a chemical property of acid, you can simply state that they turn blue litmus red. And mind it, it's a chemical property, not a physical one, because it involves a chemical reaction. They turn blue litmus red. Alright, so this is one of the chemical properties. There are 3 to 4 more that we'll study in the next class. So until then, keep shining, keep smiling, and I hope that you guys are revising. Best of luck.